In this lesson, we're going to talk about Microsoft Azure Service Bus. Azure Service Bus is a cloud-based messaging system that enables communication between multiple services, both services that we run on cloud and on premises. Using Service Bus will help us have our system more loosely coupled and distribute the workload. Let's imagine that we are building an e-commerce for our client and we have three different services. Service 1 is for handling orders that are placed by our customers around the country. Service 2 will send notifications, and the Service 3 will send invoice. So every request that Service 1 receives calls Service 2, telling Service 2 that I have received an order, send the notification or confirmation to our client with a tracking number. And the Service 3, in the other hand, will keep polling Service 1 for orders that has been shipped so that it can generate an invoice and send it to our client. Every request that is made to Service 2 will need to make another request to our outside provider or provider that is outside of our network for sending email or text message. So let's imagine that our Service 1 during the peak hours receives very many requests. And the Service 3 will keep polling Service 1 and sending emails through Service 2. We might generate the workload that Service 2 cannot handle and might cause Service 2 to drop off. Now, the reason that Service 2 can drop off is that every request it receives, it needs to call our providers outside of our network. And in case that our providers are offline, or for every request that we send to them it takes too long to process, we may add and we just add new requests to Service 2. This will generate more workload than the Service 2 can handle, and that might cause the Service 2 to drop off. Now let's introduce Azure Service Bus into our architecture. Service 1 will continue receive requests as it does during our peak hours, and for every request that it receives, it saves the order into local database and publish a message to Azure Service Bus. And there where the responsibility for Service 1 ends. After publishing a message to our Service Bus, the Service Bus will be responsible for delivering that message to services that has subscribed or needs to receive. Service 2 in this case will receive a message and call our provider for sending the notification. Service Bus will keep sending Service 2 messages only when Service 2 is ready to receive a new one. So all other messages will be placed in queue until Service 2 is ready to consume them. This goes for the same for Service 3 as well. So this system now is more loosely coupled, and it's much easier for us to release a new version of our Service 2, since messages that are placed in queue will be there when our release or our new version comes and override the old version of Service 2, and will automatically start consuming messages that has already published into the queue. In this video I'm going to talk about queues and topics. Event Hub and relays are not included, so if you want to know more about the Event Hub and the relays, there are different videos on the internet that explain how that works. I'm going to be focusing only on queues and topics in this lesson. The main difference between queue and topics is that the queues are dedicated for one-to-one communication, and the topic and subscribe technique is more like publish and subscribe. I'm gonna talk about more in depth about those, but I'm gonna start by describing how queue works. Let's imagine that we have two different services and we need them to communicate through a queue. When a publisher publishes a message, the service bus will make sure that consumer receives one copy of it. And in this case, it's going to be only one copy, regardless how many consumers we have that listening to that queue. When we work with the topics and subscriptions, publisher publish a message to a topic, and we have consumers that listens to that topic through subscriptions. So every consumer has its own subscription under a topic. So let's imagine that the publisher publish a message to a service bus. Service bus will send a copy to all of the subscriptions that are under a topic, and the consumers that are listening to those subscriptions will receive a copy of that message. There are rules that can be set on every subscription. Every subscription can have many rules. So depending on how many rules you need, you can set on a subscription. There are 3 different kind of rules that can be sent on every subscription. So there are Boolean rule or Boolean filter that helps us to tell the topic or to tell the service bus that either we are interested on the messages that are published to our topic, or we're not interested to any of those messages. So using Boolean, you either receive all messages or none of them. SQL filters help us filter the messages based on the properties that we add before we publish the message to our service bus. This means that we are not able to search within the payload. This means that we are able to search only within the user properties that we have added before we have published the message. So imagine that we are publishing a message to our service bus, and we are going to publish an order that we received from our client. So before we send it to the service bus, we can add the total amount of the order and the type of the payload. In this case, it is an order. And when we publish it, the service bus will check what kind of subscriptions, what subscriptions fulfill the criteria for receiving an order. So you can say within one subscription, I am interested only on orders that are above $500, and I'm not interested in anything else. So only orders that are above $500. So next time publisher publish a message, the service bus will make sure that subscription receive only orders that are above that total amount. Correlation filters can filter on content type. So it's a property that you set on a message that defines the payload. You can set that this payload is a type of order or is a type of person or anything. You can set a label, message ID, reply to session ID, and to. So let's imagine that service 1 or publisher 1 publish a message with order of $400 total amount, and the service bus receives it. That message will be sent only to consumer 2 and consumer 3, since consumer 1 in this case wants to have only orders above the $500. Let's imagine that one of our consumers in production environments goes offline for unknown reason, and the publisher will continue publish messages to the service bus. Service bus will save those messages locally into its local storage, since there is no consumer for consuming them. So when the consumer is back online again and start listening to the service bus will deliver those messages one by one until the queue is empty. In case that we have a problem with our consumer and the consumer cannot process the messages successfully, the service bus will deliver a message, and if in case consumer throws an exception, the service bus will keep a shadow copy of delivered message to the consumer. In this case, service bus will not delete its shadow copy, so the shadow copy will continue live into service bus until the consumer tells the service bus, now that I have processed the message that you have delivered to me successfully, you may delete your shadow copy. In cases where Azure Service Bus delivers us a message and the message cannot be processed, Service Bus will continue deliver the same message again until it exceeds the number of tries that has been configured to the service bus for every message that is going to be delivered. After that, the message will be placed on the something called dead letter queue, and the message in queue, the message after that will be delivered to our consumer. If that message cannot be processed as well, it will go to dead letter queue as well. So when working with dead letter queues, you have to be careful because that might be information that is old. I'm going to describe how you're going to work with dead letter queues in a different video, so for now let's just have it as a heads up. When we work with dead letter information or messages, we have to be careful since that information might be old and we override or we write over a fresh data that we have into our system. Now I'm going to go ahead and create a solution with a publisher and a listener, both going to be console application. And the code can be found in GitHub. I'm going to place a link in the description of this video so that you can download it. For running it locally, you're going to need an Azure Active subscription. During the time I write the code, I'm going to fast forward it so that I can walk you through code instead. I will get back to you right after I'm done with it. I have now created a solution with two console applications, the publisher and the listener, and on both I have installed the Microsoft Azure Service Bus package. All those other packages will be installed as dependencies of the Microsoft Azure Service Bus package. So this package will be installed on both the publisher and the listener. When we start the publisher, I have created the loop, so until we write the queue letter, and this will continue, the loop will continue, otherwise it will close the application. I have created a client topic where I send the service bus connection string and the topic name. The topic name is test for now, and the service bus connection string is within the app setting app config file with the app setting tag. When we want to create a message, we read the message that has been written in the console application, we transfer it to a byte, or we convert it to a byte array with all bytes that the message contains, and we create a message bus class. This is the message that comes from Microsoft Azure Service Bus. We add the body as a constructor argument, and when we send the message to the service bus. If we look at the listener, when the console application starts, we read the connection string that goes to service bus. This is the same as the publisher. We have to know what topic and what subscription we want to listen to, and we register a message handler. This can be, in this case, is an anonymous method, and this is registered for handling messages. So every message that arrives to a subscription, this will be fired, and we can receive the body of our message. We write that on the console application. If there is an exception, if an exception occurs, this will be fired, this this method, so that we can log it or do what we want to do with it. I block the listener so that we can continue receive messages, and I can write them out here. If we go ahead and start the listener. The listener is now, this is listening. Let's save now even this one, a copy of that. And we have the listener there and the publisher. So sending a message to our service bus now. See, it just our handler just fired because we received a message. We go ahead and continue with this. It will be written to our listener console. So we publish a message to a service bus, and the service bus will send the message to us, to our listener, directly. So in case that we close this one and we continue write messages to our service bus, those messages will be saved locally, as we said earlier in the video. And when we start our listener, the listener will start consume all those messages one by one. See, it just received all of them. This is the good thing, having service bus into our system. The system will become more loosely coupled, and this what should we aim for when we design complex systems. I'm going to publish this as it is. This is just a test. This is nothing that it's should be in production. It's just a hands-on example, so that you can get a feeling how this works, how Service Bus works. And if you like it, or if you have any comments on this, please send me an comment, or comment it on my video here, so that I know what to do in the next video. Thank you for watching, and have a great continue.